This is a project that I started on last fall, and it's putting a thumb on the trencher here, and kind of see. I played around with it, and I like to use cardboard for templates when I'm starting out. And I had this little Harbor Freight hydraulic kit that I was gonna try to use to operate the thumb, but in the end, after all my fiddling around and trying to work out the geometry and stuff, I just couldn't get it to really work with what I wanted to do. So, basically it's just going to be a cardboard, a copy of that cardboard thumb, or pretty close to it. So there you can see, when I start a project like this, I like to just, mock it up out of cardboard, because it's a lot easier to make changes before you get too far along, and you can kind of see where the interferences and stuff are. And I decided I was going to use that pivot pin on the behind the bucket there for the thumb to pivot on, and just make a simple one that would go up out of the way there. So my my hydraulic idea is gone now, and I'm just gonna do it with some pins on the that go through it there. So there's the start of the project, and I never got around to finishing it. So it's just sort of been laying there and waiting for me to get back to it. And finally today we got our first really rainy day for the year, and I got a chance to spend a day inside and kind of work on this. So I saw on YouTube here where a guy had added a DR ripper onto his Harbor Freight trencher. So several weeks back I had ordered this this ripper tooth from the DR company, and they shipped it out fairly quick and came UPS, and it was all packed up real good in a box. And I was pretty amazed when I got to look at it, because it is basically a really heavy duty thing, and I don't think I could have bought the metal and made it for what they charge for them. So this is gonna turn into part of the project now. Then I'm gonna be adding this along with the thumb to the trencher. So you can see it's really seems to be well made, and it's cut out like 3/4 inch steel there and 1/2 inch plate, and it looks really. They did a good job at making this. Now it does not fit the width of the standard bucket that comes on the trencher. I saw where one guy had cut one of the ears off this this tooth and moved it out and welded it back on, but I decided I wanted to go a little further and just make it so I could actually add the other buckets, because I want to get the 9-inch bucket eventually, and maybe the 16-inch, and you can see how the pins actually fit perfect into the that ripper. So about the only thing I have to mess with is the width of the backhoe arm there. So I started by basically staring at it for a while, taking a couple measurements, and seeing exactly what had to be done to make it so I could just switch it out on there. And you can see I've got to cut off those 2 bushings sticking out there, and they're slightly different on each side because it was not welded into that steel tubing perfectly centered. So the first thing I did is I just threw it up in the milling machine, and I have to warn you, this arm is really a heavy piece of steel to move around and stuff. So it does take a lot of strength to move it and get it up there. So I got that all set up, and then you can see I had marked I've got to take like 0.18 off one side of the arm, and then go back and flip the other side over and take off 0.22 to get everything back centered in there. So they didn't do a real perfect job of manufacturing it, but it's real easy for me to clean this up. And this definitely does void the warranty, but the warranty is over anyway, so I just want to make it so that I can interchange buckets in the future. So it didn't really take that long on the milling machine to cut it down. I just did a couple passes, and just kind of watch it work. You got the power feed on there that feeds it and moves everything around. And this is a really old Alliant milling machine that I bought years ago, and it's got a really old Pathfinder display on it and stuff, but it still works good. It's one of the ones that was made in Taiwan years ago, and there you can see I got that hook, so it's really a nice fit on there, and then the only thing I had to do was go back and do a little bit of deburring on it to clean up the edges there, and then just deburr the center of that hole where you got the little metal pushed into it. And these little deburring tools here are a real handy thing to have. They don't cost a lot, but they make the job easy on metal. So there's the ripper going on, and the stock pin and everything looks like it's going to work good, and everything fits on there. It's nice and tight, and really no play or anything. So I'm real happy how easy that was. Now the that linkage that drives that movement there wouldn't fit either, so I had to go back and take just about 0.4 inches off of that tubing there. So I've got this old 1950 South Bend lathe that I bought years ago, and that's really a handy thing to have around for when you have to shorten something like this, or any kind of turning work. And this is one of those old cast iron machines that probably will run forever, just like my Troy-built rototiller. So it makes just a quick job of just cleaning off that end there, and there you can see what it looks like, and it's been around forever. I got that tube there shortened down, and just a little bit of cleaning out the inside on the lathe, and then a little deburring, and it's ready to put everything together. And here you can pretty much see how everything fits inside that new tooth mount there, and just slides together. And so basically we're got a good start at being modified for the DR bucket and the ripper. And it looks like it's gonna, work pretty good with my thumb mock-up. There was a little bit of a problem with the thumb coming around on a radius and just hitting the corner of that piece of tubing. So I just had to grind it a little bit. It turned out that I just had to grind like a little bit bigger radius on it, just to make it so that ripper bucket would clear and curl all the way up. So that was an easy job with a grinder there. Someday I may just cap that end of the tube in with a piece of steel anyway, just to keep the dirt out of it. But everything there it is. Everything moves now, and looks like it's fitting good. So I think I pretty much got all my geometry worked out now, and pretty much all the problems. There's just one more area, there where that's ground out, but there's one more area where the cylinder actually mounts, and that top has the top cylinder there. I didn't want to modify the cylinder, and it just has that T tubing on top of it that the rod slides through. So I figured I'd just take and put a counterbore in these two side rods, just big enough for the that T-piece to bury in there, so you wouldn't know the difference. It would still work without modifying a cylinder. So that was a real easy job. Just threw that on the milling machine again, and went back and just used the mill that had an end cut on it and put that together. And there you can see where those pockets are, and that's where the rod of the cylinder mount will fit right in there. So now it was time to turn my piece of cardboard there for the thumb into real steel plates, and so I had to kind of draw it up and got it set up on a plasma table. And I haven't used this in like 8 months. It's been sitting there, and I did start running into some problems with my torch height control on it. You can see I got like the first cut done there without the torch height, but then this one I had a little bit of a problem where the torch went down and crashed after it fired, and then I had to go back and reset it and start it again. And I noticed I was getting some drift in my voltage too versus the height, as I was cutting this first one out. It wasn't really that bad, but I know there's something that's just not right in it, so I'm going to have to go back through and probably, there's like a whole bunch of connections and stuff to check on this, just to make sure that there's no corrosion or anything, because it's out in an unheated shop and stuff like that. So next time I get a chance, I'm going to go through everything and look at it. But anyhow, the the first plate cut nice. You can really see how easy it is once you get one of these CNC plasma cutters. This is 5/16 thick steel plate, so and it cuts through that like butter. You go a little bit slow when you're cutting that, but it's only a 40 amp machine, so I got the that first one cut out, and you can see it just kind of picks right out when you're done. So that's one side of my thumb, and now I just have to go back through and do another side. Yeah, I was so glad to finally have a rainy day out there that I could spend in the shop and get some work done on this. It's just been so dry and hot lately. Getting tired of watering, but so here's the second one, getting ready to be cut, and there you can see it did the hole fine because the torch height controller, voltage controller, wasn't turned on at the hole. But then here you can see it misfired there, and I had to run it again. And this time it actually, I had to manually start the torch to get things moving. It kind of hung up for some reason. And once it got going, I noticed that the voltage was really kind of varying, bouncing around a lot. And you can see the cut, it just kind of, the sparks change a little bit as you're going along. And normally the tip voltage on the torch actually it maintains around a 2 volt drift from the whatever you set it at, just to maintain your cutting height. But for some reason today I'm getting like a 10 volt swing across the tip there, which like I said, it isn't really right. And there you can kind of watch the tip voltage here. It's supposed to be 118, and you can see it's dropping down to 110, and swinging back up past here. So and there you can see it going off where the torch actually raises right there. The voltage goes off, and it doesn't completely go through the metal, and then it for some reason it caught back up and went back through and started cutting right again. So definitely got a bad connection somewhere. But anyhow, luckily everything cut out pretty good except for that one spot where you just saw the torch drift up on. Here you can kind of see where it just scooted along the top there, and then it went back down and started cutting again. That's not normal. They should have cut that with no problem. And here's that old woodworking bandsaw that I had in my shop. I brought it out here and put a little bit bigger pulley on it to slow it down a little bit. Put a metal cutting blade on it, and I'm using that it's working good for cutting metal. I still have to get a little bit bigger pulley because it's not quite really slow enough for the steel. It cut the aluminum good, but the blade speed's still a little bit fast for steel. But it really does do a good job, and it's handy now. So I just had to trim that one little spot out, and now I had the 2 pieces of my thumb, and then I did get some extra dross on the bottom of it, just because of the when that voltage varies, you start getting into different cut heights and seeing different symptoms on the metal. So I had to do a little bit of grinding on the bottom on basically that one needed it mostly, and I got off some of the rust and stuff, and got all the dross off there, and it'll all be sandblasted when I'm done. So this is just to clean it up a little bit. And then I actually decided to throw that arm back on the milling machine and go and machine down those back 2 pieces of tubing that protrude out too. Turned out it was going to be the best way for me to mount the thumb, and the easiest way, so I just cut them down. But I took an extra 30 thousandths off of them just for to make room for the thumb material. And then I'm doing the final opening up of the hole in those 2 parts. Nice to put that can right in front of the video there, but basically whenever I plasma cut anything and I have a critical hole that I want to keep nice, I always make it a little bit undersized, and then I'll just go back and open it up. And this one wasn't really that critical, so I'm just letting the milling machine just drive a 1-inch diameter cutter right down through the metal there. And you can see I've got them both clamped together so everything will be in perfect alignment. So pretty much here's how everything's going to go together. There's how that ripper is going to work, or the bucket, it doesn't matter which one. And then the thumb is going to swing out there, and actually there's some brackets going between them it's going to be a welded up assembly when it's done. But for right now, I'm just going to kind of leave it where it is and wait for another rainy day to do the final finish up on it. So I just thought I'd kind of start this first part of it and break it into 2 videos anyway, because it's going to be so long. So there it is. You can see the the ripper fits on there. The thumb's really started good, and I still have to put some pins in there for stopping it at different locations, and weld a couple things on there and stuff. But this is basically where I stand. So just kind of thought I'd, take you through the whole process from, how I start to work out a project like this, and right through to the, the finalizing of it. And this ripper tooth, I think, is really going to help a lot at getting out tree stumps and stuff. And, by modifying the arm so I can use the other DR buckets, I can get that 9-inch bucket later and not have to worry about it. And all they have to do is just go back and take the Harbor Freight bucket and put a couple spacers in to bring it down to that, same dimension. But otherwise, there it is there. I just have to weld in a couple spacer washers on the inside of that. So I'll be, continuing this shortly, next rainy day. Thanks for watching. Please subscribe.